I'll start with Christina.
Hey everyone, so glad to be here. As Shir said, I oversee our data strategy service line at Analytics 8. I've been doing data and analytics consulting for over 18 years, really everything end to end in the data and analytics lifecycle. So I'm a practitioner. I've been doing data engineering, analytics work, but over the last several years, I've really focused on data strategy and data governance with our customers.
I'm Matthew Mullins. Like Cheryl said, I'm the CTO and co-founder at Coginiti, where I run both product and engineering. We're a 6-year-old startup. We operate a lot in the highly regulated, highly complex space for data. And yeah, I've been doing this for Coginiti 6 years, been primarily in data for the last 15.
Amazing. Well, thank you again, both of you, for joining. I'm going to throw things over to Christina to kick us off. Here we go. Thank you.
Great, thanks. So today we'll be talking about the semantic layer imperative. So before we kind of dive in, the first slide here is sort of to set the premise. Um, Basically, we've been saying this for a long time. So Matthew, can you kind of walk us through the how we got here today?
Yeah, so this came out of I've seen a lot of chatter online about, AI ready data, and it occurred to me that this isn't we didn't just start talking about this with LLMs. So we've been, and it reminded me that, even 10 years ago, we were talking about ML and AI ready data, and we were telling, our enterprise customers and our enterprise partners, that they needed to be working on this a decade ago. Probably someone who's been doing this longer will say that, like, yeah, we've been saying this for even, more than 10 years. But, I thought about, like, I remember ads and things that I'd seen. So I did a, kind of a quick look, back in time, go in the Internet Archive to look at some, historical ad copy from data companies. And we've had SAS published their data quality for analytics back in 2013. So we've been telling companies that they need, to get their data ready and to get their data quality in shape long before anyone started talking about, using agentic use cases or talking about AI. Um, and, that's changed over time in the way we talk about some of these things. But I think a lot of the fundamental practices, as we'll talk about, today, have stayed the same. I mean, it was, uh, around 2015, Gartner comes out with data prep as a market category. So you might remember tools like Trifacta and the whole, like, data wrangling. I think Alteryx is in there, where you get these, like, kind of click and drag, data cleansing tools and data modeling tools and things like that. Where we're trying to enable people to do this. And so that's kind of the background against, which I started thinking about this is, we've been telling companies this for and organizations about this for a long time. I mean, you've been doing this longer than I have, so that's, what's your experience?
Yes, I would agree. I mean, since the beginning of doing data and analytics consulting in my career, this has been a common theme because all the best practices that applied to better leveraging data and analytics in the past are still relevant or even more relevant today, which we'll get into in the future slides. So speaking of what we're facing today, next wanted to kind of talk a little bit about LLM. So thank you everyone for joining. We've got sort of a mixed audience today. So I think it might be helpful to talk a little bit about the misconceptions of what LLMs do and don't do. It's something that I see today when I'm working with data strategy with my customers. And Matthew, I know you have to talk about it from the product perspective. So if you could maybe give your perspective on it.
Yeah, I think a lot of times there's a fundamental misunderstanding of, like, how AI agents work. Things like Claude, like ChatGPT, how these models operate, and because, so much of our experience when we chat with them does seem really magical. But the way that these models work, or the way that they're built, is, remember that when they first came out, we called them large language models. Actually, we were calling them large language models at the beginning. And that's because they're trained on a huge corpus of language data, right? They're trained on a crawl of the internet. They're trained on every book that Anthropic and OpenAI scraped from a library, or Google. And so they have this huge corpus of natural language that they're trained on. And their prediction models about, what's the appropriate words. But what they aren't trained on is data, right? They're not trained on data sets. And so I sometimes meet people that think that like, oh, I can load my CSV or I can load my database data into the model and have it do an analysis for me. And the challenge is that the models that we have today, the foundation models, these language models aren't actually able to analyze tabular data. And they're not actually good at that. And so when you try to analyze data with a model, with any of today's AI agents, they will use tools the same way that like human agents do, right? So they will use SQL, they'll use Python, they'll use various visualization libraries to access that data and to massage that data and to try and access and trying to extract insights. And so, these models can't operate against the data directly on their own. They have to use the same kind of tools that we do. And so that means that the discipline for that data has to be appropriate for those models to be able to do that. So sometimes I'll see like, people think that they can just connect like their model directly to a database, right? And so you think about like, well, what does the database like naming conventions have to be for them to be able to understand that? What does the structure of the data have to be like for those models to understand how to work with that? And the models aren't going to save you. Like they can't just come in and look at your data. Because I mean, I think of this a lot of times. We have a like a little CSV loader in our product, and sometimes even if you look at like the first 1,000 rows of a column, right? And you can say like, oh, they're all numbers, right? But until you get to, maybe on row 5,000, it switches to text, right? So like even if your model is going through and just taking a snippet off the top of those, like it doesn't have the deep understanding of the data because it can't scan all of that. And it's not as flexible as like humans are and like working with data and being able to like kind of ferret some of these things out. And so what they do well, they are good at generating SQL, right? They've been trained on every SQL book in the world. They know Kimball models, they know Inman models, they know third normal form, right? They know how to write SQL for that. They know how to write the tools. They've been trained on like every Medium article that someone wrote, right? So that's part of their training data. So they can write. They're good at using the tools when they have the appropriate context to use those tools against.
Yeah, that makes sense. And we, I think one comment that you made about like LLMs are essentially doing the same thing that people would do. So I've heard people use the reference like it's like having a team of 10 interns. And you still have to provide them, like if you had a team of 10 interns with a whole library at their disposal, all the reference books, like they could figure it out, but you still need to give them that direction. So and the context, which we'll talk more about in upcoming slides. But we're missing that back and forth that you have with like the people to people interaction where it's not just one initial question. There's the follow-up questions where you're digging in and finding adding more context to the thing that you're asking and getting more accurate answers. And like you said, the LLMs are based on this whole collection of knowledge, but the knowledge isn't weighted in any way or tailored to industries. So as we'll keep
Yeah.
seeing, a lot of the same principles of organizing data apply here.
Yeah, and we as humans carry like a lot of like tribal knowledge in our heads, like tribal context. Like I know, like you've worked on like SAP systems, right? And so like there's all these like esoteric names that like you learned at some point, right? Someone told you like this is the customer table, even though it
Yeah.
says like KNA
The
one.
Mara table is the material table.
Yeah, right, right, right. But that's not like written down, it's probably written somewhere, but you just carry that around in your head. And agents don't just carry that kind of stuff around in their head, that kind of tribal knowledge that we pass around the office and things like that.
Yeah, the nuances that make every SAP implementation different. Like in one organization, oh, they use one T code to get to a specific screen in SAP ERP, but the metric isn't right if they use it from that screen versus another one. It's all those nuances that that make up the part of the context that we need to provide when AI
Right.
starts just automatically analyzing our data for us.
Right.
All right, let's go to the next slide. So here we
Oh,
want to talk a little bit about the confidence reality gap. What did you
yeah.
want to add something?
No, I love this. Yeah.
Yeah, go ahead.
I mean, this is just, sometimes when I say this to people, they think that it's just me. And so, at the end of 25, the beginning of 26, basically like every major research firm or analyst firm, a lot of software vendors that do their own, polling are all reporting the same thing, which is we know that everybody has an AI initiative. We're 3 years into, the release of ChatGPT. And, organizations now have they have an expectation or a mandate to deliver. And so we know that like everyone is exploring operationalizing AI. And we see this from Gartner, from Harvard Business Review, from Deloitte, from Drexel. And these companies are like ready and like this is the year they're going to go into production, right? On the flip side, when you ask them about like their data readiness, they all say it's not in shape. It's not ready at all. And so you can go reference any one of these. They're basically all saying the same thing, which is everyone has a major initiative. Everyone thinks they're going to go to production. At the same time, they're all saying that their data isn't ready yet. And it's not in shape to actually be able to do this. And if you look, interestingly, in the Deloitte report, I don't know if we still have the slide for that, it's actually getting worse year over year. Um, yeah, so the readiness, the data readiness for AI is actually getting worse. This is 24 to 25. So both in terms of like the talent readiness, the governance, the data management practice that's required, the technical infrastructure for this. Um, we are in a race in which we're falling behind and being able to do this. And part of that's I think organizational. I think a lot of it is also just the sheer amount of data that we're dealing with as organizations.
And maybe the urgency of the demands on
Yeah,
whole
yeah,
enterprise as well.
yeah.
I'm curious, like if you guys listening in want to chime in if any of this resonates with you as well. I mean, the last slide we were talking about, basically you're not alone. Everyone's saying the same thing. The gap is there. You've probably seen it yourselves, or heard it. And then readiness is declining. Like, so yeah, we need to we need to move in the right direction. So we'll talk about that. A last slide here about um, how the problem is getting worse.
Yeah, this is from Gartner. 60% of AI be abandoned due to lack of AI ready data. There's a similar report from Bark as well about this. They've been doing a 10-year like longitudinal survey of corporations in Europe, and they report the same thing. And it's interesting, I think, I mean, you've done, as a services firm, you guys have done like hundreds of, probably thousands of projects where you get called in to help companies with this, right? And it's an interesting, like, there's an interesting sociological aspect to like why companies have struggled to be able to do this. I don't have a good answer. I think that like we'll talk about like modeling and things like that, but I just think a lot of these like practices, kind of fell off the radar.
I think historically, there's always been something that's new and trendy that the executives pick up on and they know they need to adopt. But um, vendors or just different, there's always an easy button that pops up. People approach that or I know we've talked before about kind of the lack of data modeling um, as a kind of like a declining skill in data engineering. So IT, like data has become a separate department in organizations, but it really shouldn't be. It's supposed to be all leading up to improving business. So it's the lack of business driven, it's the lack of following best practices that we've kind of seen across the board.
Yeah. And I remember like when I started in this field, we had this role we called the enterprise data architect, who a role that was responsible for like owning the data architecture and owning how data was integrated together. And in a lot of organizations, like that role just got completely eliminated. And we replaced it with data engineers that kind of had this full scope, and they spend a lot of time focused on data movement and things like that. But a lot of times, like they lack the business context, and those data architects were really important for like bridging the business context, with the data to be able to integrate it like that and to be able to do that modeling.
Yep. And all those problems just get magnified with AI. So like before we were missing that connection between the business and the investments that we were making. We were able to make the case. I think most companies understand that they need to invest in data. That's been a mantra that's like repeated for years. And now it's so people just throw money at the problem, and they're not kind of thinking about doing it in the right way.
Right.
Yeah, it's all common in chat. The problem isn't tech, it's the people and the particular leadership that can also help drive this as well. I think that will resonate with a lot of folks as well.
Yep.
Yeah.
Okay. So also just wanted to mention at Analytics 8, we did a research survey here and wanted to kind of highlight some of the findings there. So like we brought up some statistics from Gartner, various sources. I think it's just kind of showing that it's not a one-off thing. So one thing that we found, we surveyed 102 business and technology leaders that 88% of leaders said that their company's use of metadata was highly mature or mature, while only 59% of followers and laggards said the same. So this will kind of lead into our conversation on the semantic layer. So metadata is one way of capturing context. Semantic layer is a way of delivering it. We'll go into those details here. But so starting to kind of bridge that gap between, okay, why are these statistics declining? What can we do to address it? So how do we address it? First, we need to kind of talk about and define, like, what does success look like? What does AI ready data actually look like? Everybody throws around that term, AI ready data. Matthew, your thoughts?
Yeah. It's so our friend Joe made this comment, I think maybe like a year ago. Joe Reese had this comment on LinkedIn. All these companies were struggling to do BI and now they have to deliver on AI. And I think that's, I thought it was really funny, but also kind of deeply insightful. And I think one of the insights that like I take away from that is that the discipline that we needed to have data ready for BI is just you need that on steroids for AI. It requires a much higher degree of discipline in order to be able to deliver on that. And so that means, and here I'm thinking about this in like at the physical layer of the data. So if you're a data engineer or an analyst and you want to be able to bring an AI agent to be able to work directly against your data for modeling purposes, if you're building a gold layer, if you're building out marts and things like that, like in order to be able to do that, you have to have explicit it's schemas, right? That means explicit business names, and we still see companies like I know that 40 years ago, a lot of databases had this limitation of like 8 characters in a column name, but that hasn't been true for years. But I still see places that try and enact these like very esoteric naming conventions for tables and for columns. And so you end up with like data that's well modeled, but even their own users need a data dictionary to be able to navigate that. And if your users are going to need a data dictionary, then a model's definitely going to need a data dictionary. But the thing that we can do is like we could just use good business names directly in the database because all of our databases now support long names, and they also support, all of our tools also have things like autocomplete, right? So you don't have to worry. Like, I think sometimes people worry that they were going to get tired typing or something. You can have a long database name, you can alias it if you need to, if you're writing a query, but put the full business name in there. Like I've seen columns that were named things like I've literally seen a column named data. Like, yeah, we know that it's data, but I have to actually now open it to see what's in the column, right? And so when you have good explicit naming, then the models can not only can your humans use that, not only can your analysts and your data engineers use that, but the agents then have that as part of their context too. Like so when they ingest every tool that like ingests the schema is able to see that as part of it.
Yeah.
So,
Going back to human nature, I mean, we're still working within limitations that are no longer relevant, and
yeah.
it's hindering us in multiple ways.
Yeah, I'm thinking like specifically like we worked with a telecom here in the state of North Carolina, and they had a beautiful data model, but the naming convention was so esoteric that the models couldn't understand it, and all their users had a data dictionary to work with it, and so we're like, you guys need to go through and like have. I was like, we can fix this. We can bring the semantic layer on top, but like it'd be good if you just actually, had good naming conventions at the
Yeah.
physical.
And we'll get to, I think there's multiple ways to address that because it's not realistic for every organization to go back and just like change that. But it's just something to think about as we create net new projects and net new environments that we can as we think about like adding context to our data, there's actually lots of options for us to do that within the tools that we're already using today, and in multiple layers that'll all kind of flow through and make it easier as we get to the semantic layer.
Yeah, I think another one here, like I can skip around this, but another one, like in addition to like the good naming conventions, is having context along with the data. So every modern data platform also supports putting descriptions on both table and column names. And so you can put descriptions in as part of the metadata. I think I mean, it's ridiculously large how big this is on platforms like Snowflake and things like that. But you can actually put a lot of that context right in there. And so your tools then, as your AI agents, then, they read the schema, they read the column names, they can read those descriptions and get the context for what's in there. Those descriptions, they can tell you things about the shape of the data. They can tell you things about the context, like how it's used. They can tell you, really, anything about that data. If you think about like the kind of things that you might put in a data catalog, you can actually put that directly into the data platform. And your data transformation tools, a lot of your data transformation tools support, putting those comment fields in there and having those automatically materialize. So things like Coginiti script or DBT or something like that can do that for you. And so that goes right along, I think, with having the explicit names, is just having that context that lives kind of side by side with the data. And then the other one that I tell practitioners about um, is having defined join paths. So I know, especially like on our column oriented systems like Snowflake or Databricks or BigQuery, that they don't enforce primary key foreign key relationships, right? And so I've met a lot of practitioners that just don't use them. But when there's still a signal for an AI agent. So like our tools, our Coginity tooling, like um, when we ingest like the schema and the that those descriptions and things like that, we also know like what those primary key foreign key relationships are, or if there's other kind of key constraints that are put on there. That tells the model like, hey, this column can be joined with that column over there. Even if it's not enforced by the underlying data system, it's still a signal to the agent to be able to do that.
Yeah. We have a question in the chat that is relevant. What tools are helping provide assistance to help get data AI ready? I think, like we're looking at a slide here that's talking about examples of ways that we can get data AI ready. And I think the thing is there's a lot of tools that have features that can help in each of these areas. So that's what we're trying to highlight on this slide. And then the point of this webinar is really talking about the semantic layer. So we'll get a little bit more into like how tools can help us take advantage of context that we're adding at different levels in the data and analytics lifecycle that we're in different points that we're highlighting here, and then how that kind of leads into the semantic layer.
I selfishly want to say that Coginity does all of these, but we're not the only ones. So there are lots of tools that are able to do this. I mean, a lot of your data, like I said, a lot of your data transformation tools are able to manage like both the naming, descriptions, having comments that are materialized, having defining your join paths and things like that, and have built-in AI assistants to actually help you do this along the way. So I know like we have an internal agent called Coginiti Forge that will help data engineers actually do this practice. And I know that we're not the only ones that do that. So I think the other piece here is embedding testing. And so this is actually like a tool, this is more tool specific, but one of the things that I think is really important is having testing in your data pipeline. Um, and we call that operational governance. So like a lot of data quality tooling looks at the data after it's been materialized, right? After it's too late, right? So if you're looking in a data catalog or something like that, you're looking at like the data kind of as that, as was kind of analysis. But when you have the testing that's built in, the more that you can have, we want to shift. For us, it's like a shift left, right? If we can use something like an audit write publish or an audit write audit publish method of being able to materialize data into our data warehouse and into our data lake, then we've built in a lot of our assumptions about what the data is supposed to look like early on. So it's better to, fix it before the problem happens than try to, fix it after the fact. So we try to build as many, really rich testing, when we help our customers, whether you're using something like Coginiti script, or you're using great expectations or DBT assertions, right? You can build that testing into your operational workflows. Um,
Yeah, a follow-up to that question in the chat. We're talking about what it takes to get data AI ready, but also kind of circular reference there. Like you can also use AI to get data AI ready. And Matthew, I don't remember if you already mentioned, but like the two different AI, the two different agents that you have in Coginiti and other tools have similar features as well.
Yeah, yeah. So those are usually like human in the loop kind of agents. So you're going back and forth using the agent to like make suggestions, to actually help you do the code generation and things like that. They're huge accelerators, right? I mean, it's kind of like I think Christina, you were saying this earlier, like sometimes like having like a little army of interns that can work for you. And so they're accelerators when you can do that. Um, uh, to help speed you along the way. But it's important, I think, that like you need a human in the loop when especially when you're working at the physical data layer, because you need someone who has the business context, who has the understanding of the context of the data, of where it came from, what are the business use cases, how should these things actually be named. Um,
Yeah.
because the agents
So
are.
yeah, there's great technologies that you can leverage, and I think like maybe the moral of this slide is that there's low-hanging fruit to be had. Like there's features in multiple platforms and multiple tools, and a lot of it has to do with the processes that we want to change. Like Matthew is mentioning, a lot of these tools have the ability to have descriptions. We don't, that's an afterthought often in data engineering until we make it a priority by prioritizing context with our data,
Yeah.
which we'll need to do. So it's a bit of a top-down uh, champion, like champion that needs to be there.
Yeah. And we talk about like that. So we introduced the semantic layer here. And I do think that even the semantic layer is an abstraction over the data. And oh, we have a whole slide for it. And the semantic layer, I think, you talked about this a minute ago, is like sometimes, um, it's not possible for, like when we dealt with this telecom, okay, they had 30,000 database objects. It was really well modeled, but it had poor naming. Like I'd love for them to be able to go in and like update all the naming on that, but they'd have to change a bunch of downstream applications as well, right? With the semantic layer, we can go in and we can change the names in the semantic layer and make that available for our downstream tools and for our AI agents. And so it acts as an abstraction over the physical layer, and in that way. And it does a couple of things besides that. I guess, do we want to talk about this in general about, we have our raw source data, our model tables, and the semantic layer sits above that, as a layer that is a serving layer, as an interface. And there's different interfaces into the semantic layer. It could be JDBC, it could be ODBC, it could be a REST API or a graph API. There's a number of different interfaces into that semantic layer. But what it does is it gives you that good business naming, and it provides also like a layer of governance for both your analyst and for your apps. And so, um,
Yeah, I think maybe a point to make here is like we talked about best practices that you can start adding context even in the model tables and in the platform. And what this is all leading to is that there is a need for a semantic layer. That's like it's been universally like we started with the statistics to help build the story, the case for why the semantic layer already exists. It's already, like we're already using it, but it's just the urgency of it because of that last box on the right. We want to consistently provide that business context to multiple areas. So people are still going to be using dashboards and reports after, at least for a little while. Different AI agents are going to be interacting with it. So the semantic layer gives us that ability to have the flexibility to provide context to multiple outputs and multiple consumers.
and it's not a new technology. I mean, I know you've been working with this for probably like 20 years, right? I mean, you started business objects, right?
Yes. Yes, I love talking about business objects. I did start my career with business objects. I have a lot of nostalgia for the business objects universe because it's interesting. That was, a decade or two ago. And yeah, that was the semantic layer. And the universe got a lot of the business objects universe got a lot of the things right that we need to gather. It was pretty complex for its time. You could add context. You could define different relationships between entities. You could add synonyms. You could add aggregate awareness. There was just lots of cool features. So we're seeing tools adding similar features to that. It always existed, but just now it's more important than ever because AI is just going to go in kind of blindly and need to reference that information.
And I think the other thing that we've done is, I mean, Business Objects was solving a particular problem. It was solving actually a really similar problem that we have today, which is the problem of human users coming in and not understanding the names within the database. And and it was tied, but it was tied closely to the visualization tool. And today, like we've decoupled that semantic definition from the visualization aspect of it. And so, we have everything from like semantic views and Databricks and Snowflake to full blown, like full blown semantic layers like exist in Coginiti, universal semantic layers, which overlay multiple data platforms enable you to unify those definitions across your tools. Because the challenge was is like you had business objects and then someone else had Power BI or someone else has Tableau, and we go into organizations all the time that have they have three different BI tools across different parts of the organization or through different acquisitions, and they all have a different semantic model in them, and so they have different semantic definitions of like their KPIs, so their metrics are different. And so everyone gets this, like I asked two different people, for a report and I get different numbers because they're using different metrics that are baked into that layer. And so when we can have a common layer across those tools, then we can have that common definition, whether it's for our analyst or for our AI assistants. And I think that this is one of the important things about semantic layers is they become a governance layer for agents, because if the query can't be generated against the semantic layer, then the agent can't run it, right? So if you connect, I've seen some vendors that are like connecting MCP servers, model context protocol, for agents to connect directly to the data. And when you do that, the agent doesn't have a context of like, what's the metric, right? And so it'll either make up a metric definition, or if you, and when you ask the question slightly differently, it can change that metric, right? When you operate against the semantic layer, that measure is enforced. That layer enforces that. And so the agent then isn't able to hallucinate against the data and make up measures. We want everyone to use the same measure for customer or same churn measures and things like that. And when you get into finance, like they definitely want everybody using the same calculation. And we think that it's really important then that you're also able to version those, because like when you're in a regulated environment, like you need to know like what version of the KPI did we use? Can we roll back to that? What did it look like 2 years ago? Like how do we measure like how do we measure how that KPI changed over time, to go back and be able to see that?
I will admit that is one definite advantage over modern technologies compared to my beloved old business objects universe. We were like the version control on the semantic layer. That's really cool. I mean, that's and just so powerful. I wanted to go to the next slide because you were mentioning like MCP. So it might be helpful for some of our participants to kind of think about how data moves through the data and analytics lifecycle. So this is one way of visualizing it in this pyramid here. You kind of think about you've got your raw source data that needs to be ingested somewhere. Then we transform it. Then we make it business ready. Then we can do analytics on it. We can, from analytics, infer intelligence. With that intelligence, we can make decisions, and then we can finally, the tip of the pyramid would be, can we automate some of that? So you can see some of the organizational outcomes on the legend on the left there, but the business ready data, that's really where data or where we add the context when we're contextualizing the data, where it's becoming ready for the business. There's other use cases where maybe like data scientists are using layers below that. So there's context that we can add at each of these layers. But the important part is that we're doing that.
I see Bethany asked a really good question in the comments, in the chat, about having two truths. I would say that it's not a case of like two truths. It's more like a case of like homophone. So it was two words that sounds the same, but they have different meaning. And in the data, like oftentimes we can infer two different. We can draw both of those out of the data. And in the semantic layer, in the way that like most modern semantic layers handle this, is that you can have domains. And so you can have contracts approved within a finance domain. You can have contracts approved within a sales domain, and you can treat those within separate domains. So they're different domains of knowledge. And so you have domains within your semantic layer. So this is the organizational principle. Um,
Yeah, that's a really great question. And Shiro just brought up another one I think that was put into there related to that. So there's lots of different aspects of context, right? Like we can think about data lineage is context, right? Like we're understanding where a metric came from, what transformations happened to it along the way. Synonyms for metrics, that's other additional information that we can provide around like one single metric. And so once you have all those different pieces of content, there's data quality aspects to it, right? Like if you're using a data quality tool, you can gather information about how popular is this metric. So you kind of have an idea like, oh, if most of the organization's using this metric, that might be the one I need. What is the quality? So all these different pieces come together to give us a better story about the metrics that we're using so we can choose the right one. So going back to Bethany's question there too, like as we add, it's just another reason why if we add context and a reason why maybe like so we can think about context in a very simple matter, like just joins. But there's more information, there's more like richness to be added to it. And that's where we could get into a conversation about other ways of gathering context and organizing it, like ontologies and knowledge graphs. Um, so I'll just tease that and then we'll maybe talk about this slide and then get into that.
so I do think that like, oh, is important. So we think that like, you know, I think that synonyms are really important. We didn't mention those before, but like a lot of times when you're asking, and you may have something as an example I use a lot is like you may have orders in your data into the physical layer, right? But someone could ask a question about sales, right? Well, sales are orders, right? So the agent needs to know that, like, what are the synonyms for these things? And the semantic layer can capture those synonyms. And so, so it knows how to relate those things is really important. So, and most modern semantic layers support synonyms, and they're part of the open semantic interchange spec. As a first class citizen to have synonyms. But we think that we at Coginiti, we think that the semantic layer is an important piece. But we also think that that's part of like an entire like semantic intelligence stack where, one of the things I think that's differentiated for us is that we manage everything from when the raw data lands to that semantic serving. So all the data transformation, how that data gets transformed on your platform, all the data quality testing, the lineage from where that metric's defined back to its source layer so you can come in and see that. And you don't have to switch tools, and I think in a lot of, if you're kind of like piecing this together, like we got a semantic layer from these guys, we got this other data transformation tool, and then we're getting lineage from our catalog. When you want to expose that to an agent, you have to stitch all those tools together to be able to see that. And so we've kind of consolidated that all into one platform that we call our semantic intelligence platform. Just to make that easier because we want to have as much available context. And one of the things I think that's really cool is like the observability of the semantic layer. I think when I talk to people that like work in BI, one of the things that like we've always wanted to know is like what are the kind of questions that our stakeholders want to answer, or what are the kind of questions that they want to know. And when you can see that in the observability because you can see the question people come in and ask, and like it gives you the ability to see like where you might need to extend your semantic layer because people are asking questions that like aren't fulfilled by that, or where you might need to add additional data. And so you can see those things. But the nice thing is that it also prevents like those agents from hallucinating that at the same time. It's not going to make it up. So you get that governance in there.
Yeah, context can help prevent hallucinations. The semantic layer can help with that.
And on graphs, the one thing I'd also say is that the semantic layer is a semantic graph. It has a graph structure. And And agents are really good at traversing graph structures. And so sometimes we'll call this a semantic graph as well, because it does have, the thing is, it has the definition of all the entities, it has the join conditions, it has all the metrics that are aligned to those. And so you get that kind of similar graph structure that you would get with, say, like a knowledge graph or an ontology that's maybe rendered in like RDF or something like that. It's specific set of properties that's designed for structured data specifically. I think the case for like ontologies and things like that is a lot of times you're looking at like business context over like unstructured data and things like that, or you have like wiki kind of data that you want to encapsulate, and you want an agent to be able to navigate over that. I think those are good use cases for ontologies for unstructured. I think that for structured data, semantic layers, because they also have the cogent and governance aspect of that the ontologies lack.
The way I think about it is, so we've got like tools like Coginiti have this semantic layer that can sit across everything. Um, and so there's the semantic layer itself, like that's actually where you're storing the context. But then like how are you going to store the context in there? So that's like you could separate that into a separate concept, the semantic model. How are you going to model the data in there? How are you adding the relationships? How are you gaining? And so this brings back to like, we talk about data strategy and then now AI strategy, and like maybe there's even a context strategy because we're thinking about the whole life cycle of context and how we add it. So when you break it up like that, it's not necessarily one tool that's going to do that all for you, and it's probably a combination of tools and processes that'll do it. So when we're thinking about how we want to create our semantic model, we need to be gathering the business context, and we need to be providing an easy way for that context to be maintained. We have to keep that loop in place so that the business can keep providing feedback on that and make changes to that context. And I think there's a lot of different methods for achieving that part of it. So like, it might be helpful to separate the tool that you're using to house that with how we maintain it. And for some organizations, maybe you can do it all within one tool. For other organizations, maybe you're using a separate data governance tool to act as that like user-friendly interface for the business to update their definitions or to add their blessings on certain metrics, so their um, data quality like measurements or ratings. Maybe an organization is building an ontology for unstructured data as well, and like there's overlap where we can benefit. If we're storing that in any kind of like programmatic way, like RDF, we can like there's a need to build a strategy for how all those things will flow together, so we're not reinventing the wheel and doing and repeating those processes multiple times.
What do we have next?
All
We had
right.
a
Yeah,
quick
we have
question around the semantic layer again. Will this semantic layer support data mesh and data fabric architectures?
Ours does. And so data mesh, I think, is more of a organizational principle around how you organize like decentralized teams to be able to work on data. So you're managing data as a product, and you may have like distributed throughout your organization. So you have people that work in finance and in product and in sales and in engineering, who are delivering that. And so we are a collaborative platform, so all those players can play in our, at least for Coginiti, all those players can play within there and produce data products, and you can unify those in the semantic layer. You will need to work across teams in order to be able to consolidate that. And for data fabric, this is a play like if you mean data fabric across, say, something like a Trino or Athena or Dremio or something like that, that's then able to federate queries across those. We support Fabrics as an execution engine. Also, or if you want your semantic layer then to lay across, say, we operate across both, on-prem and cloud and these kind of like hybrid environments. And so we're able to talk to like your classic like Teradata or even like a DB2, but also BigQuery and Snowflake. And so we can unify across those kind of platforms like that. So having the semantic layer is compatible both with data mesh and with Fabric, which one is a technology and one I think of really as like a socio-technical
the lifestyle.
it's a lifestyle choice. Yeah. Yeah. Oh, yeah. So
Great.
I think we mentioned this before, right?
Yeah, we
Yeah.
talked a little bit about this. So I think we've been talking a lot about semantic layers, and we've talked about the features that you can leverage in various platforms. So one thing that might be helpful as you're all not kind of navigating, well, how do I get my data AI ready, and what kind of semantic layer do I need? Um, the term semantic layer gets used a lot, so it's all products, lots of products have their different versions of it. But it's kind of helpful to think about them in these two buckets, right? So you'll have your platform native semantic layers. And we can give some examples of those versus your universal semantic layer tools like Coginiti and AtScale and Cube that can provide one consistent semantic layer over all of your platforms. And I think, well, at least at Analytics 8, we're always trying to meet organizations where they're at, and a lot of times it's a journey, not a destination, right? So there might be valid use cases to use one for a period of time and then change. But the important thing is to understand what the differences are and what the values are, and then compare those against your organizational needs and see what the cost to benefit comparison will be.
Yeah, I think there's really like two places on the platform native side too, because there's the semantic layer that lives in that last mile kind of like BI tool. And then there's also like the newer semantic views that actually live in the data platform. I think that the challenge for the ones that live in the data platform is so many customers, especially at enterprise scale, they have three different data platforms, right? And so you want something, unless you're like all in on Snowflake or all in on Databricks or BigQuery. You want something that's able to, I always joke that like every enterprise has three data warehouses, the one they're on, the one they're moving to, and the one they just got in a merger and acquisition. And sometimes they'll have even more than that. And so
Sadly
you
true.
need something that's able to scale across those. That's where the universal semantic layer comes in.
Bethany just asked, is it realistic to have one universal semantic layer for a company that has 50 plus data domains, or how do we determine how to break it down to manage it effectively? I'll start and then I'll pass it to you, Matthew. But like from a services perspective, like that's something that we run into a lot, right? Like, and so it comes down to we often help our customers kind of build a roadmap out for. Obviously, we don't need to address all 50 at once. Let's work on some prioritization. Let's talk about like foundational and structural changes that we can make to provide a better environment for the business to leverage the value from data and analytics. And let's do that by identifying some key domains to start with. So, incremental approach is often a very successful approach. But Matthew, anything you want to add on, at least from Coginiti's perspective?
I really agree with that. I think of the universal aspect. The biggest part of the universal is our ability to span across multiple platforms, is that universal connectivity, not the kind of like one ring to rule them all aspect of having. We can serve multiple semantic layers. We can serve multiple semantic graphs for different use cases, for different domains, for different parts of the organization, if we need to. So it doesn't necessarily all have to be unified into one single semantic layer to span across everything, especially if you think about an organization that like maybe does a lot of M&A and things like that. You may have something that like sits on the side for a while before you decide to integrate it. Or you may have something that you're getting ready to spin out and you want to carve that out. Right. And so I think that's going to be like a real like organization by organization choice about how they choose to do that.
And I'll add to, I think having a universal semantic layer option makes it more realistic, right? If you have 50 plus data domains, which is a large amount of data domains, but I'm assuming that means like there's replication across maybe different like acquisitions or like franchise model. Um, that's a lot to do in one semantic layer. Then if you have a universal one, like one of the benefits of that is, it takes time to govern data. And this is why why data lakes, I feel like in lake houses became popular, because there's this idea of like we want to make data available. We don't want it all to have to go through the bottleneck of being governed. Otherwise, we're limiting the business and what they have access to. So let's prioritize and let's put some data in a raw form, give people access to that, and then also spend the time on a subset of that data to govern it. um, I feel like with the universal semantic layer, it gives you that flexibility too, right? Like, so if you have um, the multiple acquisitions, for example, and multiple ERPs, multiple platforms, you can go ahead and start at least, right? Like have the semantic layer over all of it and then work incrementally to govern the data. So at least the data is available, the data is useful. And we'll be sensitive to like PHI or PII, of course, like that's a separate category. But in general, like there's a lot of data that can be useful and can be made available faster, like in a rapid prototyping type model.
Yeah.
Another question about how does semantic layer deal with traditional data pipelines? So my thought on that is, well, I think we had a slide that kind of showed the life cycle, right? Like you would do, you can use traditional data pipelines to massage your data, to model your data before it gets to the semantic layer, and or you can use the semantic layer to model your data as well. So that kind of touches back on what I was just describing. You could have this like hybrid model where maybe you're doing traditional transformations, and then maybe you're just pointing like Coginiti semantic layer against not data that's not modeled yet, and you're using the semantic layer to add some organization.
One of the funny things about being an abstraction is like sometimes a semantic entity has a one-to-one mapping to a physical table, but sometimes the semantic entity is actually a query over what's underneath. And so one of the things we talked about sometimes with people that need like quick AI wins is that we can use the semantic layer as an abstraction and we can kind of fix some of your data problems or a number of your data problems in the semantic layer. We can create entities that don't actually exist in the underlying data platform so you're able to get wins for the organization. But we do recommend that you then go clean up and model the data appropriately underneath. But it is a way for us to do like, kind of a rapid delivery, where we can define those things in the semantic layer.
All right, 5-minute warning. Thanks, Shiro. So just two slides left here. So one thing to think about is like what separates the leaders from the laggards. It's not model sophistication. Matthew, you want to talk a little bit about the categories here?
Well, I think it's having those semantic foundations, like they're language models. So unless you clean up the language in your physical data and at the semantic layer, then they're not going to be successful being able to use those AI agents. You need good operational governance. I think that's the data quality testing throughout, and your discipline across. This is the thing that we said early on is like whatever you did for BI, like AI requires you to do that on steroids. Like your standards for data quality and data delivery just have to be so much higher than they were today. And I think that it forces data organizations to have to like kind of rise up in terms of like their execution.
Great. Last slide. So we've covered a lot of ground. Thanks everybody for joining. Just 5 kind of takeaways here, steps that you can do to strengthen your semantic foundation. So first one here, audit your semantic definitions. If a metric is defined differently across teams, fix it before you add AI. So this is not a new problem that we solve. We can do this with data governance. We can do this just with best practices and requirements gathering. We can do this with a variety of tools. That's a process thing. Number 2, embed context alongside data. So Matthew talked about leveraging features that we have in the pipeline tools today, making use of descriptions and definitions. That all that is good information that can just it's an easy way of adding context that can flow through to the last layer. 3, automate quality gates. Matthew, you want to talk about this one?
Yeah, just encode your assumptions right in your data test. So there's, you want to make silent failure impossible. Like go look at the QA practices in software engineering and bring them into data. We want to shift that left. We want that data quality testing earlier in our process.
4, treat governance as infrastructure, policies enforced in the data layer, not bolted on after the fact. And 5, develop a model that represents the business and gives AI the right context. So that comes back to a point we kind of made in the beginning, right? Like data modeling was always important. It was underutilized, and now it's even more important. So we work a lot with our customers at Analytics 8 on helping to design data models that are going to make their data more flexible, more business driven, and coincidentally easier to use with AI. So it's kind of win-win. All right, we've got 2 minutes left. Shira, I see at least one question in here.
Yeah, I had one I wanted to ask. So I'll just read it out loud and paraphrase a little bit. I have tried to build a semantic layer over my 25-year career and have had varied levels of success and failures. Business objects MicroStrategy, and more recently, the context around metadata, business glossary relationships. How is AI making it easier to build a semantic layer, or are we still dependent on leadership sponsoring, significant stewardship lift, and other resource-intensive operations?
Yeah, so from a services perspective, we've had lots of success with building semantic layers, and we do it incrementally. We help prioritize business use cases, and we build infrastructure. So we build out the metadata layer incrementally, uh, getting those near-term wins while building towards the um, larger wins in the future. So I think, but how that has evolved, so that's stayed the same. How it's evolved is yes, there are accelerators that we can use now where we're leveraging AI to automatically scan metadata in existing systems, understand how the business is using data. These are all hints. It doesn't take away the need to have the business and the person-to-person interaction. Like that's still critical, but it's an accelerator. Like it gives us context. It helps us be more thorough when we're doing the business stakeholder interviews to determine how we want to best organize the data in a semantic layer so that it can serve the business better. Um,
I,
yeah, Matthew.
I think that, but you need strong executive sponsorship to be able to do this. I mean, I think everybody, we said this at the beginning, every organization has an AI strategy, and there's no AI strategy without a data strategy. And, when someone says, like, we have an AI strategy, the AI strategy should fund the data strategy because they're not going to be successful without it. And so you can use the AI strategy as a lever for the data strategy. And they're, and to implement these things. Otherwise, they're not going to be successful.
Yep, agreed. All right, we're only a minute
We
over.
should,
How'd we do, Shira?
we should make a shirt on that, Matthew. Data strategy needs, or every AI strategy needs a data strategy. We'll print those out for the next trade show.
That'd be great. I see people dropping. I just wanted to thank everybody for joining. This is a really fun topic. I love talking about it. We love talking about it. I hope it was helpful.
Yeah, reach out if you have questions.
Yeah, thank you everyone for joining. We will be following up, I think, both from Matthews and Coginiti and from Analytics 8. We'll deliver that AI research piece as well. And just feel free to ask us questions. We're happy to help. So thank you again so much for joining, and we'll be sending that recording your way as well.
Thanks, everyone.
Thanks, everyone.
Thanks. Bye.
Bye-bye. Thank you.